Hello and welcome back to the PopcornFX channel to the part 3 of the trail tutorial. Let's start by creating a new layer, deactivate the loop system and set the spawn count to infinite. And add a particle evolver spawner. And comment out their velocity. And after that, we'll change the velocity of the parent particles by setting the velocity to a shape. So we'll create a sample shape, rename it to target. And then, set the velocity in the spawner script by sampling the target's shape position. And after that, we'll just adjust the position and properties to our needs. Add some gravity in the physics. This is a Unity project, so the up axis is the Y in this example, so we'll set it to -9.8. Increase the lifetime of the parent particle, and we'll readjust the target shape here to have a bit more variety in the effect. This is more like it. Alright, now we'll be talking about the spawn metrics. There's distance and time. There's also custom, which is an advanced option where you can use both time and distance as well as other variables. We'll be covering distance in this example. To explain it in a simple way, the parent particle spawns a particle depending on the distance it travels. And we set the distance traveled in the spawn interval. So if we increase the distance traveled, we'll have less particles spawning. And if we decrease it, we'll have more child particles spawning. We'll talk a bit more about the user-oriented matrix in a bit. What I'm going to do is jump right up to the local space spawn. This mostly works with distance spawn metric. To see that, we're going to reduce the number of parent particles spawned to 1 instead of 5. So we'll click on layer 1 and change the spawn count to 1. And change the spawn interval to 0.2 in the particle evolver. When the local spawn is unchecked, and when we move the spawner in the editor, only the initial spawning point is changed when we move it. So we'll have to add a local space evolver, and we'll add it in the parent particle. Place it before the physics evolver, and now we'll check the local space spawn explanation. If true, spawn interpolations between frames will be local space, meaning that when it's false, the interpolation will happen in world space. So if we move the spawner, it's going to spawn the particles in world space while we move it. And when we check the local space spawn and move the spawner, the interpolation will be in local space in the particle layer. So when we move the spawner, we'll see a space between every child. And if you want the whole system to move with the spawner, you need to add a local space evolver to the child particles. Place it before the physics because order matters. And now when you move the spawner, the whole system moves swiftly. Be sure to check the local space spawner, because if it's not checked and you move the system, you'll have weird artifacts. Let's put the local space back on. And now, let's tackle the user-oriented spawn matrix. It's manually to set the up and or the forward axis depending on a variable of the mother particle. Right now, it's checked off, and we'll go to the spawner script of the spawner evolver to uncomment the velocity that is set to scene axis up. And I'll turn on debug mode to see the directions of the velocity vectors. We can see that the velocity of the child particles are moving. And if we go to the evolver spawner options and set the velocity of the parent particle to the up axis field and turn on the use-oriented spawn matrix, we'll notice that the velocity of these particles change. Their up axis is now the velocity of the mother particle when it's spawned. So we can use this to make something like making these particles spawn in circles around the mother particle. Let's get down to that. We'll comment out the velocity. Create a ribbon renderer by right-clicking on renderers and choosing the renderer ribbon and deleting the billboard. Let's choose a texture and set the position of these particles using the method we used in the earlier tutorials. It's always favorable to use float3 SUF or float3 SFU. If we want the particles to rotate around the mother particle, we'll need to multiply the variable t with a higher number. This is looking a bit low resolution, so we'll decrease the interval spawner. We'll set it to 0.05. This is looking much better. And if we want to tweak the size of the circles that the child particles make, we'll need to multiply it by the spawner life ratio. So I'll add the field SLR and multiply the position by this variable. And after this, we'll make the trail start small and finish with the current size. And that's also by multiplying it by the SLR. And decrease the life ratio to decrease the length of the trail. And now it's time to make the trail grow depending on the life ratio. So we'll add an evolver script, then add sizeCoef in the fields, and replace the size by sizeCoef in the spawner script. And in the evolver script, write down size equals sizeCoef multiplied by life ratio. And finally, we'll make the trail fade at the end. That's by multiplying the color by 1 minus life ratio. This way, at the beginning of its lifetime, the particle will be opaque, and by the time the particle reaches the end of its life, it'll be transparent. And over here, we'll deactivate the infinite spawn and turn on the particle loop system. And now we'll tackle the custom spawn interval scale field. It's used as a dynamic multiplier to the spawn interval. Another way to put it, it multiplies the time that the particle takes before spawning another particle. So we'll fill in the variable interval scale, and Popcorn will give us a warning. It's because we need to add that variable in the fields of the parent particle. So we'll go to the parent particle and pass that variable in the fields. The trail will disappear because we need to set that variable in the spawner script. And we'll create an attribute for it, this way we can change it directly without touching the script. So when it's set to 1, it's going to be the default value. Right here, we'll just adjust the timing and loop delay of the effect to show one particle at a time. And when we change the C interval scale, we'll have less definition of the ribbon. Since the spawn multiplier has gone up, so instead of spawning each second X particles, it'll spawn each second multiplied by the C interval scale X particles. Meaning that the lower C interval scale, the more definition the trail will have, and vice versa. Enough of the custom spawn interval scale field. Let's check out the custom spawn metric scale field. So basically, it's a metric multiplier. We'll fill in a variable metric scale added to the fields of the mother particle, and set the value of that to 1 in the spawner script of the mother particle. So now, if we increase the value, it'll increase the definition of the trail and spawns more particle. And the best way we can use this is by using it with LOD or even adding a global scale to the effect. We'll add an attribute and call it global scale. Then multiply the size and velocity by the global scale. We'll also need to multiply the acceleration by the global scale. And the variable used for it is axle that we can see in the physics evolver. We'll create a float3 field for it. Then set the values of the acceleration in the physics evolver to 0. And in the spawner script, set the axle with the float3 SFU 00 minus 9.8 and multiply it with the global scale. We also forgot to multiply the sizeCoef and position of the child particle with the global scale. But we'll notice that when we change the global scale, the definition of the trail will not change with it. This is where we need to use the interval metric scale that is inversely proportional to the global scale. So we'll go to the mother particle and set the metric scale to 1 divided by global scale. And this way, the definition of the trail is maintained when we change the global scale. Let's check out the differences. When we increase the global scale, and when we reduce it. And now you guys know how to use the ribbons with the evolver spawner. Feel free to use these techniques to make awesome looking effects. And don't hesitate to ask us any questions regarding ribbons or anything else. Well, this brings us to the end of this tutorial. Give us a like if you found it helpful, and make sure you subscribe to our channel so you don't miss the next videos and tutorials. See you then, and thank you for watching.